Okay, welcome back to our fourth session of today. So we are going to continue with this MATLAB file. I want to first clarify that there was no mistake actually. I mean, there was a mistake, but that's not about the value of gamma. The problem is that, let me just show you. No, not this one. Just a second. The problem was I used, in the benchmark calibration, I used strategy 1. Okay, so right here, as I said, we have two different strategies. I use strategy 1, so that requires eta to be about 0.53, and then alpha would be 0.08. Okay, so when I put these values back in, then gamma is equal to that number, right? So when I do that, so ideally, of course, I should type gamma here. So I should type here gamma as a function of alpha and eta, right? But I corrected that for here. So eta is 0.53, then alpha is alpha eta divided by eta, it is equal to 0.08. Okay, so when we do that, let me comment these things as well. So when I run this, as you see, this is GDP per worker. It exhibits exponential growth under the benchmark parameter values. Then we run the benchmark model. So let me first clarify. So let me first delete these data. So this command is save. So first I create the benchmark output file. So I look at education. So I can actually add G here. Okay, so let's look at the growth rate as well. So I'm taking education spending, GDP, consumption, utility, and growth rate. Okay, and I define these as the benchmark output file. So these are, this is just a matrix. And then I save this data within the mat file, BM for benchmark. Okay, so when I run this now, oops, there's a mistake. Why? Oh, because G has a different size, right? Okay, G has a different size, so let's clarify the correct size for G. So G is what? G has 9.1, and these are 10.1. So okay, that's what we should do is to do something like that. Okay, this for Y, C, and U. So when I do that, I think it will work. Oops, it doesn't. Okay, what's your problem? Okay, then let's do this. E equals E19, Y equals Y19, C equals C19, U equals U9. Okay. All right, now it works. Now, if you look at here, there is BM, the benchmark data. And now we want to run the model for the alternative experiment. So I comment this and I create the high subsidy version. So in the high subsidy version, sigma will be equal to 0.28. So I come here and change sigma, okay, and run the model again. Now this is recorded as HS mat, right? So HS for high subsidy, okay? Then I also comment this out. Then I have close all, clear. Now I clear everything and only upload the experiment data. Okay. Now the experiment data must be loaded. Yes, it is exactly right there. So now I can draw some figures. Okay. So what I can do is to create one figure with plot E. So that's the education expenditure. So this must be, let's say, in red circles. And then, of course, this is not E. This is benchmark first column, right? Benchmark first column is benchmark education. This is this hold on command. So then by holding on this figure, I'm drawing high subsidy education, and it becomes two circles. And I'm holding it off, creating a legend that says benchmark and higher education subsidy. Okay. So when I just run this, the variables are already loaded. The graph is there, as you see. Right? You see the graph, right?
Yes.
Okay. So as you see, the benchmark path is here for education spend. So you can actually add the title, education spending. Now you can do it for, you can do it with subplot option. So you can draw 4 figures. Subplot. So subplot 2 to 2 would be, let's say, what is it? Output or GDP per worker. Okay. Then you would have consumption, I believe, the third one. Yes, consumption here. 2, 2, 2, 3. And then the fourth one, you would have utility or welfare. Right? The fourth one is welfare. So you can compare all this. You see? Actually, we can drop the legend for the other 3. And run it again. Yes. So as you see, the consumption effect GDP effect and education effect are similar because the utility function is logarithmic, right? It's homothetic. And the welfare effect, of course, with different measurement units is there. So this doesn't actually show you much because you want to understand the welfare increase in percentage terms, right? So you may draw another figure, figure 2, that plots the high subsidy welfare, was the fourth column, divided by benchmark. Benchmark 4. Okay. So now it's going to be drawn relative to the benchmark, right? So if I run it, figure 2, as you see, now you can understand the percentage change, right? In the after 25 years, it is less than 0.5%, very small welfare effect. So in the very long run, of course, this welfare effect grows because now the economy is growing permanently faster, right? If you look at the growth rates, the growth rate differences are, again, relative to the benchmark, the growth rate difference is permanently larger, like 9% larger, right? The growth rate is 9% larger permanently. So this permanent fast growth translates into increasing welfare effect over the long run, right? That will be growth. Now you may ask even different questions. No, but we have to run it first. I'm sorry. No. So you can run the model for even longer horizons and to see how the effects change. Now you can also run other types of experiments. One experiment would be increasing the returns to education parameter. So imagine creating a version with high return. Now in that experiment, sigma would be again 23%, but eta would be like 60%. Okay, so when you do that, save it as high return economy. Okay, you can actually do it. You can have many different counterfactual experiments. So high return economy would have 23% of sigma, and eta would be 60%. Okay. So for now, let's comment these things out first to be not too confused. I'm just running this for saving the high return economy results. Okay, so I run it. It is there. After this, let's comment this out and uncomment this. Now I can add the high return economy to all my figures, right? High return. Oh, that would be like cross terms, diamonds with magenta color. So high return 1 high return 2, high return 3, high return 4, and we can create relative to benchmark effects. High return 4, and the legend would be high subsidy and high return. And here the legend would be higher returns to education. Higher subsidy to education. Higher subsidy to education, higher returns to education. So high subsidy, high return. Similarly, you have for growth rates, high subsidy, high return. Okay, so this is titled, this is welfare. Welfare relative to benchmark. And this is growth rate relative to benchmark. Now I can, I guess, run it. Right? Okay, I'm not saving anything. So when I run it, okay, as you see, so let's start with this one. Higher returns to education create a huge effect. So it is possibly too large. Okay. You can take logs of consumption, education spending, and GDP per worker to smooth these things out. But as you see, there is this huge welfare effect now, right? So relatively, if you look at the, so if you look at relative to the benchmark, so in terms of welfare, there's a very large effect, okay, compared to the, so the high return option gives you very fast welfare increases, and the growth rate jumps at a too high a level, right? So this growth rate is about 2.5 times larger than the benchmark, okay? So then, of course, you should ask, how come this, society would realize a higher returns to education? That, of course, requires some reform, but here we are doing it as a free lunch. So I'm just saying that what if this economy has a high returns to education? Okay, so it is totally counterfactual, but you can, as I discussed in the lecture, you can create some benchmarking here. So once again, you create a value for eta that would imply the same growth rate with higher subsidy. Then you look at the welfare effect. Okay, you can do all sorts of things. In that particular simple model, the results will be the same, because if you are equating the growth rates, since growth rate is fixed, there will be the exact welfare effect on, because of the high return assumption. So now let me stop here. If you have questions, I can send you the code so you can actually play with it. As you see, we just wrote it, right? Where it's not so simple models with only forward recursion, right? You are not doing any fancy dynamic programming stuff in this simple model. So it works as a very smooth forward recursion. As long as you know the initial values and as long as you know the parameters, you can basically run the model, right, and compute everything accordingly. your assignment will be actually even simpler than this, because I'm gonna give you the parameter values, I guess. So you don't have to deal with the calibration at this moment. You're just gonna first learn simulating the model, and it will be a heterogeneous agent model. But I will be of help if you need guidance. So let me now pause here, and if you have questions, I can answer them.
It was very clear enough. Thank you very much.
So I'm sorry. So obviously, the software is an important part of all this. I'm using MATLAB because like 20 years I'm using MATLAB, or like 18 years. So I'm very familiar with it. I find it costly to switch to R or Python at this moment because MATLAB solves my problems. But I recommend you, if you are new to programming, and if you want to learn something from the scratch, maybe you should try R or Python or Julia or any other newer stuff. If you are really into computing, I'm not just saying to just two of you, but all the others that watch this video over YouTube. Actually, Fortran, which I never used, is the fastest of, as far as I know, it is the fastest computing algorithm that you can actually learn, but it is not very straightforward, as I believe. For most of the growth stuff, especially if you are not going to deal with the heterogeneous agents models, MATLAB is totally fine, and it has very nice symbolic math toolbox, so you can actually create symbolic expressions in MATLAB. And so let me just show you. This is what I like most. Is in Mathematica, you can create symbolic stuff in MATLAB. Okay, let's say ABCX. You can write an equation now, because now these are symbols. A times x squared plus b times x plus c, right? Now you can find the solution to this equation in terms of x. So if you run it, now as you see, the solution is there. You see it, right? No, you don't see it. I'm just sorry, just a second.
No.
Okay, I realized that. Okay, now what I implemented was this command. Okay, first I define symbols A, B, C, and X. Then I define an equation using these symbols. Then equation becomes a symbolic expression as well, as you see. Okay. Then I call the solve command. Solve command requires you to specify the equation to be solved and the variable to be solved. So the solution is, as you know, minus b plus the square root of b squared minus 4 times a times c divided by 2 times a, right? So you can do many fancy stuff. You can take the derivative of this with respect to x. You can actually do LaTeX expression, all right? So if you do this, it gives you the LaTeX expression So you directly copy this and paste it into LaTeX. Okay. So there are many other, of course, nice things about MATLAB. What I show you is the very first fundamentals. If you want to learn MATLAB, what I recommend is my advisor's, it's my advisor Luz Hendricks MATLAB notes. So it is in his website, I guess. So he has somewhere over here some MATLAB tips. MATLAB and programming right here. So there is this very nice MATLAB introduction by Luz Hendricks. I never studied that, but I just looked at it and it's very useful. For instance, there is a growth model here. I've never seen that. Okay, so that's the Bellman equation that you learn. As you see, so the MATLAB solution is here. Okay, of course, in GitHub. You see, I think I showed you something similar in math class, right? Last semester. So you can learn a lot over there as well. Okay. Luz Hendricks. So let me share the link actually. It was here. MATLAB introduction. Let me share the link over chat. Stop sharing. Chat. Okay, so now if you have questions, ask me, and if you have comments, you can also share, and let me clarify if something is not very clear. So let me also share this file with you. No, but this one. Okay, let's. So this is saved. My computer. Okay. It's right here. Oh, by the way, one other reason that you can use MATLAB, I mean, you should use MATLAB, our university has a license for it. Okay? So with your Hacettepe University username, you can sign up for what we call yazılım deposu, and then you can download the most recent version and install it with a license. Okay. Now I'm all yours. Questions, comments, clarifications, if any.
Thank you.
Okay, then. So I'm going to post your assignment, and then I'm going to post some instructions as well. That will be your third or fourth assignment. Remember that by the end of the semester, you have to complete at least 3 of them. And then next week, let me check what is on our agenda. Okay, next week we're going to discuss poverty traps. Lovely topic. We're going to see a couple of different poverty trap models, and then we're going to continue with the 5th assignment. Okay.
Okay.
All right. Thank you very much. Bye bye.
Bye-bye.
Thank you. Bye bye.